Hello, pre-algebra students. Mr. Lawrence here, and we are examining perimeter and area of, and I hope you know all these shapes. You should by now. Squares, rectangles, rhombi. And I like to say rhombi. It's a lot of fun. It's plural of rhombus, in case you're wondering. And that's a parallelogram. There we go. Remember, the rhombi is like a tired square, meaning all four sides are the same. And the parallelogram is like a tired rectangle, okay? We've got opposite sides the same, congruent that is, and they're also parallel. So these two sides are parallel to each other, and those two sides are parallel to each other, okay? Just like in a rectangle. The difference is the angles aren't all 90 degrees. All right. Now, there's actually like 4 different formulas for these things, and I don't understand why. I think it's ridiculous to do that. I use one formula. In fact, I use the same formula for squares, rectangles, rhombi, parallelogram, trapezoids, and triangles. I just might have to adjust it a little bit. In fact, even circles, I kind of use the same formula, but I'll explain that later. All right, so first of all, let's define what perimeter and area are. Perimeter is the distance around. Oh, what word is that? I don't know. I guess I'm making up new words now. The power has gone to my head. Around a polygon. Okay, so in other words, it's the outside, the distance around a polygon. If I give you a polygon, say I'll give you an octagon here. Okay, and I told you that this side was 5 inches, and that side was 4 inches, and this was 3 inches, and then 5, and then 4, and then 3 again, and then 6, and I don't know, 7. Just making it up. I'm not sure if this polygon can exist, but I'm just demonstrating a point. I would add up all these numbers. So like I got a pair of 5s there, so I'm up to 10. 7 and 3 make 10 more. 6 and 4 make 10. And then these two make 7. So my answer would be 37 inches for my perimeter. Okay, it's just the distance around an object, or a polygon more specifically. Okay, area. Area. The definition of area is the space inside a two-dimensional shape. Okay, because it's not limited to polygons. Circles have area as well. All right, now there's usually a formula for area. And again, when I'm doing area of quadrilaterals, usually I like to use base times height. Base times height. Now the problem is, a lot of you don't know what a base is. You think that a base is the side is resting on. It is not. I'm going to do this here and show you that we got a right triangle here. And I'm going to put a rectangle in here like that. And there we go. And maybe I'll do a square too. Okay. And I'll show you the right angle. And hold on one second. Okay, now many of you are going to say, well, you know, that in this triangle, this is the base and this is the height. And I wouldn't necessarily disagree with you. But what if the triangle would turn this way? You might want to call the base this, and then you're not sure what to call the height, okay? Well, the trick is, what just happened there? The trick is that the base and height have to come together at a right angle. So let me move this back to where it was and turn this back. Okay. You could call that the base and height. Or, so one thing you could do here is you could turn this. Notice the base and height move with the shape because they're going with the right angle. Now that'll bother some of you because you're looking at this and you go, how is that the base and height? Well, you don't have to do that. You could call this one the base here that you know, elementary school days tells you, oh, the base the side is resting on. But then what you need to do is you need to drop a line segment that is perpendicular to the base. And then this becomes your height. And sometimes that's more work to do because you might not know the length of that segment there. Okay, it's not actually part of the triangle. Okay, same thing goes with a rectangle. You might call, this bottom one here the base. And it's not wrong to do that. And that the height, because that kind of looks like it. But the trick is you got to have a right angle. If you have a right angle, then one of them's your height and one of them's your base. Okay, so you could call this the base if you wanted to, and this the height when you're doing the problem. The key is that the base and height come together at a right angle. Do you think that's important? Because I've only said it like 800 times. All right, so let's go here and see if you can figure out the perimeter of this parallelogram. All right, well, go ahead and see if you can do it on your own. When you're ready to see my solution, pause it. My solution for the perimeter is 34 meters. You might be looking at this wondering how I got 34 meters. Well, I know that in a parallelogram, the opposite sides are congruent. And so I add 12 plus 12 plus 5 plus 5, and that's how I'm getting 34. Okay, now some of you are saying, Mr. Lawrence, I just do 5 plus 12, and then I multiply it by 2. Well, guess what that equals? 34 meters, right? So I really don't care how you do it as long as you're doing it in a valid way that gets you the right answer. All right, see what you can do with area now. Now be careful. I got to warn you, I'm trying to trick you. Whoa, what just happened there? See if you can figure out the area of this parallelogram. All right, hopefully you're ready to see my solution. And my solution is that right now you can't do this problem. Did that on purpose because remember we said the base and the height come together at a right angle. Do you see a right angle in this shape at all? No, I don't either. We need the base and height to come together at a right angle, so I need to drop a perpendicular line segment down. And if I don't have that right angle, I don't know the base and height. Now you could say, well, my base is 12 meters, the distance from here to here, but you still can't figure out the height. 5's not the height. I mean, when they measure your height at the doctor, okay, here you are at the doctor, and they're going to measure your height. Do they take, a measurement in this direction? No. Geez, they could make you 80 feet tall if they wanted to, if they did that. No, they take it perpendicular to the ground. So the ground is kind of like your base, and your height makes a right angle with the base, perpendicular. Okay, so we need to know the length of that segment that I dropped down there. And there you go, 4 meters. So now to do the area of this parallelogram, I'm going to do 4 times 12. And it's actually 4 meters times 12 meters. So I'm going to get 48. But this is very important, and a lot of you slough it off. I did 4 times 12 to get 48, right? But I got to do meters times meters. What do you suppose meters times meters is? Can't just be meters. I mean, think about it. Is 3 times 3 3? Is 7 times 7 7? No, then meters times meters can't be meters. Hey, do you know an easier way to say 3 times 3? I could say 3 to the second power, couldn't I? Isn't 7 times 7 7 to the second power? Hey, what do you suppose 12 times 12 is? Isn't it 12 to the second power? Of course it is. Well, in this case, I'm going to do meters times meters is meters to the second power. All right, so there's your answer. Okay, we're going to do one more example. Now we'll get some practice in class tomorrow. This time I have a rhombus, and I'm going to tell you that this is 10 centimeters on the side. I want you to find the perimeter, and I want you to find the area, which, there we go, area. Okay. Well, hopefully you know the perimeter is 40 centimeters. How do I know? I took a walk around the rhombus. I went 10 centimeters, 10 more, now 20, now I've gone 30, and now I've gone 40. Hopefully you know you can't do the area because I haven't given you enough information. I have to drop in that perpendicular piece, and then you also have to know how long that perpendicular piece is. And that's going to be 10. I'll tell you what, let's make it 9 centimeters. So I'm going to do the base times the height, which of course will be 10 centimeters times 9 centimeters. And that will be 90. And then centimeters times centimeters is centimeters squared. All right, there you go. That's your lesson for today. Don't worry, we're going to get lots of practice with this over the next couple days. Mr. Lawrence signing off. Good night, everybody.